Hello everyone, I'm Ananya Kumari of MTech IT 5th semester, and in this video I will be solving the section A of first internal question paper of data science. Let's begin. The first question is, give 5 commonly used statistical measure to characterize dispersion in complaint derived scores. Discuss where each measure is useful in the context of a large complaint repository. So 5 commonly used measures are range. It tells how widely scored are spread by subtracting the minimum score and the maximum score. It measures the average speed of square deviation of all values from the mean. And larger variance means stronger variation in complaints. Standard deviation, it is the square root of variance and expresses how far each score is typically lies from the mean or the central in the same unit as data. Interquartile range, it is the difference between the third quartile and the first quartile. It represents the spread of the middle 50% of the complaint that is not affected by extreme cases. It is also used for outlier detection, the formula of which we can see in the upcoming questions. Here I will only explain the theory of it. Mean absolute deviation, it is the average of all the absolute deviation of each value from the mean, and it captures variability without squaring values. And these dispersion methods are useful for large complaint repository because complaint related scores like severity, evidence, strength, harm, impact, sentiments, etc. often show huge variation. Statistical dispersion help the DSS understand how consistent and inconsistent complaints are. For example, range helps identify the extreme span of variation in complaint score. Standard deviation and variance help detect whether complaints are clustered or scattered. IQR and MAD helps understanding typical variation without getting affected by rare extreme values. Altogether, they allow the complaint management system to identify patterns, spot unusual complaints, and cluster similar cases, compare variation across different complaint categories. So this was for the first question. The second question, there is a sorted data which is the evidence strength score of 30 sample complaints, and there are 4 questions that we need to tackle in this. Actually, there is one more I want to edit. I will edit this. There is one more question that we need to calculate the mid range. So here the first question is, what are the modes? Comment on modality. If it is uni, bi or trimodal. If there is one mode, then it is unimodal. If there is two modes, there are two modes, it is bimodal. And if there are more than 2 modes, then it is trimodal. So the value that occurs the highest number of times is 33. In the dataset you can see 33 occurs more frequently than any other. It appears 4 times. Therefore, the mode is 33. Since the mode is only 3, the data is mainly unimodal. Solving the second question, we need to estimate the first quartile and the third quartile. So, the first quartile, we calculate this. For this, we need to divide the data into 4 parts. So in the first quartile, we need to calculate the sum of the total number. Actually, we just need to add 1 to the total number of data sets and divide it by 4. So when we do this, we get 7.75. We need to see the 7.75th value. So the 7th value and the 8th value are both 20. So the Q1 is equal to 20. Here we have divided the data set into a set of 4, and the first set, the value of Q1 will be 20. For Q3, it will be 3 into n plus 1 divided by 4, and we need to choose 20 3.25th value, so 23rd and 24th values are both 35, so Q3 will be 35. And the box plot here, we calculate the mid-range by calculating the sum of the minimum value and the maximum value and dividing it by 2. So here the mid-range is found to be 36.5. And here you can see in the box plot, the minimum is 3, which is the minimum value of the data set, and the maximum is 70 up there, which is the maximum value in the data set. And there, the lower part of the box here, see there is 20, which is Q1, and in the middle there is medium, which is median, and the end of the box contains 35, which is Q3. And now we need to explain about QQ plot and quantile plot. So quantile plot shows the quantiles of one data set only. It is used for identifying skewness and outliers in that single data sets. So it is mainly used for outlier detection, while the QQ plot compares the quantiles of two distribution. For example, the evidence score versus normal distribution, or the evidence score versus target distribution. If the plotted points lie close to a straight line, two distributions are similar, otherwise dissimilar. Therefore, a DSS can use a QQ plot to check whether evidence score follow the expected distribution pattern or not. So this was all for the second question. Moving towards the third one, we have a data set. The severity index 1 to 100 of complaints is bin into the following range. So we have range in which this sort of complaints lie, and using this group data, we need to estimate the approximate mean severity and comment on the shape of the severity distribution in terms of skewness and concentration of cases. Here we calculate the total number of elements, or the total number of complaints lying in the data ranges, which is 3194. Then we calculate the mean position by dividing it by 2, which is 1597th complaint. We accumulate frequency until we pass the median position. So then up to 1 to 5 there is 200, up to 6 to 15 there is 200 previous frequency plus the frequency of this class, which is 650. And we are doing this till we get the median position. And up to 16 and 20 we have 650 plus 300, which is 950. And up to 21 to 50 we have 950 plus 1500, we get 2450. So it is larger than 1597. So here the complaint lie in this range. So our complaint lies in 21 to 50 severity bit. Therefore, approximate median severity between 21 is between 21 and 50. Now we have a last question, which is question 4. A distinct intake sample of 18 complaints provide the following values of age and incident impact. There is a table where there is age and corresponding incident impact. Using the above data, we need to calculate or compute the mean, median, standard deviation, or both age and incident impact percentage. Construct box plot for age impact percentage. Comment on the scatter plot and QQ plot for the above data set in the context of incident impact and age. So first of all, answering the A subpart, we need to calculate statistics for age. So we are calculating mean of age, for which we have summed up all the ages, dividing it by the total number of ages or total number of data sets, we get 44.22 years. And then we sort this data and find the median position, which comes out to be, since the number of observation is even, then we calculate median this way: 18 plus 1 divided by 2. So the median position turns out to be 9.5. And Actually, position turns out to be 9.5. So the average of 9th value and the 10th value will be 54 plus 54 divided by 2. So 54 years. Standard deviation is calculated and it turns out to be 12.75 after substitution in the standard formula and full calculation. I have not shown the calculation here, but it is calculated this way. We uh, first calculate the sum of we first calculate the mean, then we calculate the difference of each item and the mean, and then we square up that difference dividing by n, and then finding the square root of this is how we calculate standard deviation. So the same for incident impact. Here the mean turns out to be 31.47. Then we sort the data and median position is 9.5. So median impact is the average of 9th and 10th value. So the average of 9th and 10th value is 31.3%. Again, standard deviation is calculated to be approximately 4.92. Here I have drawn the box plot for the same. The above box plot is the above box plot is for the age, and the downward box plot is for percentage. In the above box plot, you can see 23 is minimum, 31 is Q1 first quantile, 54 is median, and 58 is Q3, and 61 is the maximum value. Here for the percentage or incident impact, we have the minimum value of 25.9 and Q1 27.6, median 31.3, and Q3 34.4, and the maximum 42.5. Moving towards the last sub part, we need to explain scatter plot and QQ plot observation. So if we plot age on x-axis against impact on y-axis, the points show a weak positive relationship. A younger complaint tend to report lower impact values, and impact tends to become slightly higher among old complaints. There is no sharp linear trend, but there is a mild upward pattern. While in QQ observation, if age is compared against a normal distribution, the QQ plot will show right skew, that is more value in older age range. If impact is compared against normal distribution in QQ plot, it will appear closer to normal distributed with slight right skew with no heavy outliers. So this is all for the last question. Now I would like to thank you all for listening to my video. Thank you so much.